The aim of this experiment is to demonstrate the planar and three-dimensional printing of conductive microelectrodes via direct write assembly. Direct write assembly is a deposition technique which is composed of a computer-controlled three-axis translation stage, ink, nozzle, and air supply. In this printing method, highly concentrated inks are extruded through a fine cylindrical nozzle whose diameters range from 0.1 to 250 microns. Due to the viscoelastic ink characteristics, direct write assembly enables self-supporting spanning features. To date, a wide range of inks, including those composed of ceramic, organic, metal, polymer, and sol gel materials, have been developed for this printing approach.
The main advantage of this technique over existing methods such as inkjet printing is that direct write assembly of complex 3D structure is possible without using any lithography or template methods.
Although this method provides insight into conductive inks for electronic and optoelectronic applications, it can also be applied to other material systems that can be used for biomedical scaffolds and sensors.
Visualizing this procedure is critical because the ink rheology and printing expertise strongly influence the quality of the printed structures. Demonstrating this procedure is Bak-An, a postdoc, and Analisa Russo, a PhD student from my laboratory.
Silver nanoparticle inks are prepared by first dissolving a blend of 5,000 and 50,000 molecular weight acrylic acid in a mixture of water and diethanolamine. The polymer acts as a capping agent to control the size of the silver nanoparticle.